Wisdom, beginning with a prayer.
King of glory, thank you for today. We thank you for what you have done for us. We thank you for the gift of life, King of glory. We pray that this lesson, whatever the teacher teaches us, we get it. King of glory, we pray that we don't disturb the teacher and we end this lesson very well. I've prayed in Jesus' name. Amen.
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 Thank you so much, Ahereza.
Amen.
Okay.
Amen.
Okay. Girls, today we are going to try to shortchange the notes. We are not going to follow those notes religiously. We are going to try to make some shortcuts here and there so that we don't over-delay over this topic. I hope we are clear. So whatever we are going to be talking about, you take also some time off, try to understand your notes better, but let us do some small shortcutting here and there because the notes may be bulky for nothing. When the major concepts, you can achieve them in a shorter version. So that's why we are trying, that's what we are going to try to do this lesson. I want us to pick the basic points that we discussed. We say that moments are vectors. What does that mean? What does that mean? Moments are vectors. What does that mean?
They have both magnitude and direction.
Very good. They have both magnitude and direction. What is their basic directions? What directions do we talk about in the moments?
Clockwise and
Anticlockwise.
Clockwise or anticlockwise. Number two, what is a moment? A force. What is a moment of a force?
It is the product of distance.
Person, just one person. Let us take control of this class because all of you have answers. So we need to mute all of you, and I'm going to take Destiny. You define a moment.
Moment of a force is the product of a force on the perpendicular distance to the line of action of the force.
From the what?
Through the line of action of the force.
There are some statements that are wrong, and that is the definition. A moment of a force must be well defined. Refer to your notes, those who have them, and give us a proper definition of a moment of a force. The moment definitions are paraphrased and you lose meaning, the point is gone. Yet that's why we capture most of our marks. So we must not play around with definitions, girls. I hope you get the point. They must not lose meaning by paraphrasing them. I hope you're together. So can I get the correct definition of a moment that was paraphrased and therefore it became wrong? Ayoki. Ayoki.
Moment of a force about a point is the product of the force and the perpendicular distance from the point to the line of action of the force.
Okay, that is better. Please, girls, capture that. That is the definition of a moment of a force. We had left when we had established a principle of moments. I think that's where we left last. Now I'm going to ask one of you to give me, I want to ask questions across different classes. So if you are all those from 2K, because I think is from 2K, all those from 2K, put down your arms or your hands, and I receive hands only from the other class. Okay. Is Priscilla not from 2? Yes, Priscilla is from 2H. Priscilla has run away. She's there. Yeah, Priscilla, 2H.
Okay. The principle of moments states that when a body is in equilibrium under the action of forces, the sum of clockwise moments about any point is equal to the sum of anti-clockwise moments about the same point.
So whoever is near you, mommy or daddy, should buy you a sweet on my behalf. Thank you very much.
You're welcome. But it's you, not them.
Eh?
Yes.
They are buying on my behalf. Okay, those are the basics that we have learned so far, and those are the things that where we are going to be basing our knowledge. I want to add certain things about bodies that are in equilibrium. There are conditions of a body to be in equilibrium. Somebody who has her notes, I'm now looking at the conditions that must be satisfied for a body to be in equilibrium. That body is being acted upon by a system. Now somebody has started singing for us. Is 3 over is 2. Kali. Is Laure Nan Ntumbwe is she Natumanya? What class are you in?
2H.
2H, no. I want somebody from another class.
2N at Kwasa Kelly. 2N.
2N. At Kwasa Kelly, please. I hope you have your notes.
Yes, teacher.
Yes, I want you to read about
conditions for a body to be in equilibrium. The sum of forces acting in one direction is equal to the sum of forces acting in the opposite direction, i.e., the net resultant force on the body is 0.
Very beautiful. Thank you for that condition. In most cases, for us to summarize this by saying the sum of the upward forces is equal to the sum of the downward forces. That's what we are going to be using mostly in what we want to capture today. So you can as well remember the sum of the upward forces is equal to the sum of the downward forces. But the actual definition is what she has told us, what Kelly has told us, what is in your notes, that the sum of forces acting in one direction must be equal to the sum of forces acting in the opposite direction. Okay, that was the first condition, Kelly. The second one.
The sum of clockwise moments about any point is equal to the sum of anticlockwise moments about the same point.
So the second condition which you have read, what is it also called? What is its other name? It must be familiar.
I think it's the sum of clockwise moments is equal to the sum of anticlockwise
yes,
moments.
But that has a name that can also be called, it is baptized a name.
Principle of moment.
Exactly. Who has given us that answer?
Destiny.
It is destiny. Okay? It is also called the principle of moment. Is that okay? So whenever we are dealing with what we are going to be dealing with, because today we are going to be carrying you into what we refer to as numerical examples about moments, we want to get used to them as fast as we can, because they're a common question. We want to get there, and then we do, because we're going to be using those conditions for a body to be in equilibrium. Is that okay, girls? So whoever is interested in understanding this topic must memorize those, but after memorizing, make sure you understand them. There is one thing that we do. We first memorize, but as we memorize and we become active, we start understanding what we are talking about. I hope that makes sense.
Yes.
Am I making sense?
Yes, teacher.
I'm giving you a minute to memorize them. And I'm going to pick on anybody without asking, and you tell me those conditions for equilibrium. So I'm giving you a minute starting from now. Now I'm quiet, I'm counting my minute.
Wait, what? I didn't hear the question.
Who is repeating the question for us? I've told you.
Memorize the conditions for
equilibrium. Memorize the conditions for equilibrium. There are two conditions. After you have memorized them, I'm going to ask anybody at random to tell me those conditions. You are at home, so it is only Jesus who's doing this.
I'm really trying to like Excuse me, teacher, someone is talking. We can't hear you.
Okay, I hope everybody is quiet. I've told you, read through the conditions of movement. What is wrong with your goodness? Okay.
So what needs us to mute them so that you
Mr. Bato, I wish you could mute these girls so that we can select them as they give us the answers. We are getting a lot of feedback. Okay, my minute is done. Kirabo, Trinity. The conditions for equilibrium are Kirabo is passing. We go to the next person. Isabella. Isabella, the conditions for equilibrium are Isabella is absent with apology. Hope, who is Hope? Hope one. Hope Asimwe. What are the conditions for equilibrium?
The sum of upward forces is equal to the sum of downward forces. Then the sum of clockwise moments about any point is equal to the sum of anti-clockwise moments about the same point.
Thank you so much, Hope. Let me select one more person for emphasis. Hey, is this girl called Raquel? Where is she? I've seen a Raquel here. That's a name that used to happen some time back. Okay. Kagoya. Kagoya Christine. Home Kisha. I see. Kagoya, wish. Kagoya Christine. The conditions, I'm giving you an opportunity to echo them so that everybody gets them. Kagoya is not present. Kilu. Buliaba Letitia, can you repeat those conditions before we move on? Because whatever we are going to deal with, we have to understand those conditions. Okay, there's somebody who has put up an arm. Let us go with that one. Whose arm is this? I cannot see Mr. Salsima. What you want to put up? You see this arm?
There's Dove Tandaza, Divine, Deborah.
All the arms are up. Pick those ones.
Okay, Tandaza, your hand has been up. Unmute and submit.
Teacher, the sum of upward forces is equal to sum of downward forces, and the sum of clockwise moments about any point is equal to the sum of anti-clockwise moments about the point.
Okay, I told you that when we are talking about the calculations, in most cases, most of our scenarios are upward forces and downward forces. But the actual, what is in your notes is not upward forces and downward forces. It is the sum of forces in one direction is equal to the sum of forces acting in the opposite direction. So the sum of forces acting on a body in one direction is equal to the sum of forces acting on the body in the opposite direction. That's what we want to keep into our first rule. I hope that is clear, girls. So I don't want you to get so much used to upward and downward. It is the sum of forces acting on a body in one direction is equal to the sum of forces acting on the body in the opposite direction. Are we clear about that, girls? Can we now move on?
Yes.
Yes, teacher.
Okay.
Yes.
Excuse me, who has a question?
Teacher, can we get the diagrams to explain more about the...
I wanted to eliminate the diagrams. I wanted you to concentrate on your notes. Now, this is where I know whether people have notes or not.
Excuse
That's
me.
why I'm not showing you my notes.
For diagrams.
You don't have the diagrams.
Teacher, we don't have the diagrams.
Yes, we don't.
You could not draw lines, diagrams of lines. I think that was laziness. Those diagrams are very clear in the notes.
We have
They told us not to
There
draw
are some
that.
diagrams in the notes.
You go back to the notes and look for them.
Some diagrams in the notes, but you told us that we'll draw them
If
together
you
in
have
the
the notes,
lessons.
please go back and draw the diagrams. Those diagrams, share them. But we are going to be discussing challenges. The questions now. I'm going to be
Teacher, you're the ones who told us to draw the diagram.
but teacher, this is but teacher. But teacher, tap the video.
But Mr. Salino.
But teacher, can you tap Mr. Senjo Elsam that box and you see what is on the board?
Excuse me, teacher.
Yes,
I have a
please.
question. Teacher, I don't understand the upward and downward forces.
I have not talked about upward and downward forces. I told you that when we are using our calculations, we shall understand that better. Okay? So, do you see that dialogue with Mr. Senjore? You must see the blackboard clearly.
Yes, we can see it.
Okay. Now, this is what you're trying to say. I am drawing a body. A body is usually represented by a straight line, simply a straight line. Okay, in most cases, most of these bodies which we are talking about, which we are going to be discussing, are either meter rules or beams or something that will be called a name. Okay, that is our body. Now, I will draw a certain point anywhere. I don't have to be very accurate. That simple triangle. What does that simple triangle? The moment you see that simple triangle, what does it represent?
Yes, sir.
The pivot.
The pivot. That's our turning point. So we are saying we have a system of forces.
Okay.
So we draw those arrows. I'm not following what is in that diagram because I'm not being accurate. I told you I'm not showing you notes. It's better that you understand. Okay? Okay. So down here. Okay, so this is our body, this is our pivot, it is our turning point. Now, there are forces that are acting in one direction. What is that direction that you see? If force 1, force 2, force 3 are all acting in the same direction. And what is that direction?
Upward.
That is upward. So then we have two forces, F4 and F5. What is the direction in which they are acting?
Downward.
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 So the first rule says that sum of forces acting in one direction is equal to sum of forces acting in opposite direction. That is our first condition. that the sum of forces acting in one direction is equal to the sum of forces acting in the opposite direction. I hope that point has been captured. So can you tell me the direction? What do I do? What does it mean?
F1
F1
plus F2
plus F2
plus F3
F3
is equal to F4 plus F5
plus F5. Brilliant. Who is that one? You get my suite for me in absentia. Who is that one?
Ivy.
Who was that one? Who guided us properly? Yeah?
the Ivy to H.
Thank you so much. But whenever we are becoming practical, the upward forces are equal to the downward forces. That's what we say. But in what we are trying to say, sum of forces acting in one direction is equal to sum of forces acting in the opposite direction. That is our first condition. I hope you have captured that condition properly. It is in your notes. I don't think you really need to write it down.
Divine has a hand up for your notes.
Yes, Divine has a hand up.
Divine unmute. Divine, you have your hand up. Okay, she has put it down. Casemira Noella, unmute and submit.
I wanted to ask, can't we also consider the clockwise and anti-clockwise directions if we're explaining the first condition?
Can't you use
the clockwise and anti-clockwise direction about the first condition?
You are now talking about direction, but this clockwise and anti-clockwise, clockwise and anti-clockwise come as a result of each forces creating a turning. We say that whenever a force acts upon a body and there is a pivot, like you are opening a door, the result is a turning. That door will turn along its hinges. And the turn is what is called anti-clockwise or a clockwise turn. So it is not the direction of the line of action of the force. Here we are talking about the direction of the individual forces acting on the body. That's the first rule. That's what it is talking about. It is not talking about their effect. Their effect is captured in the second condition. And I hope you could give me the second condition.
Yeah, the second condition is the sum of clockwise moments about
anti-clockwise moments
is equals to the sum of clockwise
about any. There is that statement that we always jump, but it is about any point. About any point, is equal to
the sum of clockwise moments about the same point.
Sum of clockwise moments about what?
The same point.
About the same point. Thank you so much. They are really bright. Because 2 years in lockdown and you are still this bright. Your parents are lucky. Okay. Now, can we try to move on and we understand this? We are going to look at the individual forces and ignore all the other forces and we see what effect they have about the turn. I hope this is easy. You can see this. I will come back to this diagram. Now, ignore all these other forces that are acting on this body. And we consider F1 and we see, suppose I have F1, F1 is located here. How would it make the body? Where would it make it to move about the people? Will it move down or to move upwards?
Down.
About the pivot, this is my pivot. So I'm looking at F1, it is going into that direction. So what's the direction of the turning caused by F1?
Clockwise.
Clockwise.
Okay, that is clockwise. So this is clockwise. Whenever I write a C, that is clockwise moment. CM is a clockwise moment. Now I got the second force, F2, about the pivot. It will be pulling this body upwards. So what will be the turning?
Anticlockwise.
Anticlockwise.
ACM.
Anticlockwise.
Beautiful. You have come in late, but you are still okay. Now this one, what about F3?
Anticlockwise.
It is also anti-clockwise. Now we go to the downward forces. F4. How will it cause? What turning will it cause?
Anticlockwise.
Anticlockwise. That is okay. So this is ACM. What about force 5?
Clockwise.
Clockwise. Is that okay? That is force 5. Now, I'm going to, because I'm talking about moment, all distances are measured from the pivot P. All distances are measured from that point. So F1, let us take that distance to be what? D1. Oh, I'm okay. F2, measure that distance as
D2.
D2. F3 will measure this distance to be
D3.
the whole of this distance, by the way, from here up to there. That is D3. F4, we measure that distance, we call it D4. And this distance, we call it
D5.
D5.
D5. Now, this condition, how do we use it? We say the sum of anticlockwise moments about a point is equal to sum of anticlockwise moments about the same point. So can you tell me, name the anticlockwise moments and put them this side? So what is the first moment? The first anticlockwise moment?
F2.
F2 times
Plus D3.
It is a moment is the force times the distance. Remember that. So it is F2 times D2. That is the first anticlockwise moment, isn't it?
Yes.
Yes.
What's the second one? The second anticlockwise moment?
Plus
F3 times D3.
F3. Good. Times D3.
D3.
Is there any other anticlockwise moment?
No.
F4 times D4.
F4 times D4. We are done with those moments, isn't it?
Yes.
So they are equal to which moments?
F1 times D1
times
Times D1 plus
5 times
F5
D5.
5
times
times
D5. Now, please, I want you to take note of something. Where was I getting? How was I measuring the distances? I was measuring those distances from which point?
From the pivot.
Pivot to the force. Is that clear?
Yes.
All distances are measured from the pivot to the line of action of the force. You are brilliant, girls. You are very, very brilliant because this is what we have. So these two equations or these two formulas may be applied for most of our equations where we are dealing with the moments. I hope you are clear. So these two equations are what are very, very important or very crucial when we are going to be carrying out calculations for moments. For those who have captured this, please try to capture it, and then we move to the simple problems that we encounter in trying to solve these kind of questions. We are going to try to get new questions so that you will in your notes for practice. Are we okay?
Yes. Excuse me, teacher.
Mr. Sally, I see a hand up.
Okay. Yes, Lugolobi Shona Lisa, may you submit?
Yes, teacher, I was asking that when you're
when you're writing the principles, how come we didn't mention them having to be in equilibrium? Or is it,
conditions?
do they not have to be in equilibrium to have those principles?
Okay, who can assist me answer Lugolobi's question? These are two principles. They are principles for what?
Natkunda, may you respond to this first question? Natkunda, unmute. Oh, you have a question?
I have a question. Yes.
Okay.
Somebody first assist us. What are we doing? These two things. Can you keep quiet, please? These two rules, all these two conditions have been set for a body that is state. I had a lot of interference. I don't think
the microphones are open. Mr. Joel, may you help us to mute the microphone? Joel Bato.
I don't think you can hear it.
Girls, can you unmute your and then we hear? We were setting these conditions because the body was in a certain state. Can we know that state?
Equilibrium.
This body must be in equilibrium. And what did we say equilibrium was? The other word we can use for equilibrium.
Balancing.
Balancing.
The body must be balancing. So I forgotten the person was the last question, but these are conditions that must be satisfied. It was shown for a body to be in. So this only applies, or it is only true. These equations we are trying to write down are only true if a body is in equilibrium or it is balancing.
Oh, okay, thank you.
You are welcome. Is that okay?
Yes.
I think the arms have disappeared.
Someone had a question.
Yes.
Natkunda, you had a question. May you unmute and submit?
Yes, I'm sorry to take you back, but then I don't know how we like determine if it's a clockwise moment or anti-clockwise.
Do you see the blackboard?
Yes.
Yes.
Okay. If you see the blackboard, I am going to look at force one, F1. This is the force I'm concentrating on. Ignore all the other forces. This is the pivot. How will this force pull the meter ruler? Will it be pulling it upwards or downwards?
Upwards.
So it will cause that turning. And what is the direction of that turning?
Pardon, teacher?
What is the direction of this turning? In what direction is the ruler turning?
Yeah, it's clockwise.
So that's how we determine whether a moment is clockwise or anti-clockwise. So we ignore all the other forces, consider only that force, and we see how the body will behave. By the way, you don't even have to do a lot. Okay, but for this one, you just pull it up, you can use your pen, but when you get used, you don't even have to do much what I'm doing. You just know the directions, depending on where the force is located in relationship to the pivot.
Oh, okay, thank you, teacher.
Okay, so that's how we identify the anti-clockwise and the clockwise moment, by taking the behavior or the action of the force individually on that body. Okay, we ignore all the other forces, we see what effect that force will have. And then that's why we identify which will cause clockwise moments and which will become anti-clockwise moments. So please, these conditions only apply if the body is in a state of equilibrium. A state of equilibrium, we define it very well, that the body must be balancing about a point. I hope that is clear. Is that okay, girls?
Yes.
Are we okay?
Yes. Yeah. Yes.
Yes, I've heard that. Good. That. Now I want you to remind you about a certain word. Do you see what I've written on the board? What is this word?
Uniform body. Uniform body.
Uniform body. What do we know about a uniform body? Anything we have mentioned about a uniform body?
To single, unmute, and submit.
It is 100. It is 1 meter.
1
It is
meter.
100 centimeters.
Thank you very much. That's what remembers about the uniform body. Anybody who remembers something? I see an arm up.
Someone remind us what we said about uniform bodies. Carabo, angel, unmute, and submit.
It is one in which the particles are uniformly distributed.
Okay, thank you so much. Any other? Appellant, unmute, and submit.
Its center of gravity is at the middle.
Thanks for reminding us. Who was that one?
Pellan.
Pellan. Pellan is in what class?
Pellan, you did put a stream.
Oh, 2S. Sorry.
2AC. You see the challenge we have, girls. There are people who are in touch with their notes. Whenever you give a wrong answer, you must know that there is a competitor who is always in her work. And I really put everyone up. I consider you girls, I really salute you because you have not been in school for a long time. So when we see people like Pellan who are constantly in their books, it is really a big challenge. Okay, so thank you so much, Pellan. Please keep in your notes a uniform body, because these words are specific to a certain topic. But a uniform body is a body whose center of gravity is located in the center. That is what we have. Okay, so we must remember, because these are common words that we are going to be using. Okay, are we ready to go, guys? Because I want to remove this and we move to our first example.
Yes.
Okay, we are ready to go.
Watch the solution of some examples which are very simple. That means girls, you can write the question down. Some in your revision book, because you may not have space in a notes if you already wrote the note. Such that we try to apply what you have learned.
Teacher, the board is not very clear. It's blurry.
Okay, no, it's okay. Let's adjust the screen maybe. Okay, let's adjust the laptop. How is it now?
It's fine there. Much better.
I have a question.
So we have we want to start with a relatively simple question. Why have I selected this question? It is very simple. You have examples in your notes, but if you follow through those examples, here I want to see people who are attentive and people who are non-attentive, because depending on only what you have, in most cases, it makes some people lose I mean, they don't follow the notes, or they are not as attentive as they actually should be. So we are creating a new question that you are going to write, and then you see what we really have learned. Okay? The keywords I'm going to point out. Anybody who can tell me what keywords should be pointed out in this question? One of the keywords. When you look at a question, can you tell me one of the keywords that I must look out for?
Okay, someone.
I think I should add this uniform meter rule.
Faith Rebecca, S2N, unmute and submit.
There's a word added there, a uniform meter rule. Please, I had forgotten that. Should be a uniform meter rule.
Faith Rebecca, unmute and submit.
Keywords we are going to be looking out for in this question. Number one, we look at the word uniform.
The word uniform meter rule. So what information does that give us?
It tells us, number one, that the center of gravity of this uniform meter rule is at the middle, and also the particles in this meter rule are uniformly distributed.
So, okay, you have given us more information than we require, but in most cases, I think she has pointed out the major word. Yes. That the weight of this meter rule is concentrated at that middle point. So what's the middle point?
70 centimeters.
70
the middle point of a uniform meter rule. How long is a meter rule?
100 centimeters.
What is its center?
50. The length of a meter rule is 100, so the center is.
So the COG is at the 50 centimeter mark. Is that okay? Because the body is uniform. So the center of gravity will be at the 50 centimeter mark. They have given us some more information. What is that? If the rule has
mass of 100 grams.
So the mass of rule M is how many grams?
100.
100 grams. So we in most cases need the weight, because whenever we are given mass, we are supposed to get the weight of the ruler. So let us first convert this mass to grams. What do I do?
I mean kilograms.
Yes, I want to, to kilograms. What do I do?
100 grams divided by 1,000.
Divide by
1,000.
And what do I get?
0.1.
0.1 kilograms. Now I want to get the weight of the ruler. W is equal to mg. So what do I do?
0.1 times 10.
1 times 10.
Times. What do I get?
1.
1 Newton. Very good, very good. Now, I have established that I'm going to be, my ruler is actually, in actual sense, has a weight of 1 Newton. So the next thing, do you still see the board?
Yes.
Okay, I'm going to draw my diagram here. This diagram is going to become very serious in trying to give us an illustration. I don't know, I should have done this. And that is my diagram. So on my diagram, I'm going to mark, this is a 0 mark, that is 0. What is this mark here?
100
centimeters. That is 100 centimeters. Now I need a point at the 50 centimeter mark. What is at the 50 centimeter mark?
The center of gravity.
The center of gravity. At the center of gravity, I have a force there. Which force is there?
Gravity.
What force acts at the center of gravity? This is the COG.
Gravitational force.
What force acts at the center of gravity?
The resultant force.
Yeah, define the center of gravity. Define a center of gravity.
Center of gravity.
The center of gravity is the point where
The one object is concentrated.
Gravity
is a point of application of the resultant force on a body to apply attraction on it.
Concentrated. Okay. Yeah.
The point of
isn't it?
The point where.
Teacher, can you say where the resultant force is 0?
It's the weight.
The center of gravity is where all the weight of the meter rule acts from. That's where the weight acts from, and that weight is 1 Newton. That's the center of gravity. It is located at the 50 centimeter mark because our meter rule is a uniform body. I hope that is okay.
Yes.
Okay, so where is the meter rule pivoted? According to that question. At the 70
centimeter mark.
70 centimeter mark. I have a 70 centimeter mark. What do I put there at the 70 centimeter mark?
The pivot.
What is the symbol for a pivot? Triangle. That's very good. So at the 70 centimeter mark, I have a pivot. Now I have something also at the 90 centimeter mark. What is there? What is suspended at the 90 centimeter mark?
Mass of 100. Mass of 1.
Determine the mass that must balance this weight of the ruler and is suspended at the 10 centimeter mark. So at the 10 centimeter mark, I have another weight which I don't know. Can you give me a name for that weight? I think this one I don't. Okay. Can you give me a name, a letter for that weight?
X.
Or we use X, but X is not a very good. X, Y.
Z.
S.
Let's use the P. Let's use P. I hope we are okay. I've used the letter P. Now there's something else that I need. I need distances. Distances from the pivot. So can you give the distances from the pivot? What's the distance of the weight from the pivot?
It's square.
Eh?
20 centimeters.
20 centimeters.
So there's an answer. Tell us how many
20 centimeters.
20 That's 20 minus 50.
Distance is D1. So D1 is equal to
Your brain 20 centimeters.
70 minus 250, which gives us
20 centimeters. And we can't see your screen.
How much shall we can hear you?
See and hear everything.
With your network.
Shall continue.
Okay. I've been prompted to continue. Now, what about the second distance? Can we change this distance to? I don't need it. So what about this other distance? I have another distance here.
20 centimeters.
Tell me if I get it.
90 minus
90 minus 70 gives me also 20 centimeters. So I have got distance 1 and distance 2. Now this body is balancing. So there is in equilibrium. So what do we do?
Can't hear you.
It is because you are talking.
Enrique board.
And I hope you are writing down what is necessary.
Yes.
Okay, now we are moving. Do they see this part? I don't know. Okay, so we are going to the second rule for equilibrium. For equilibrium. What the second condition for equilibrium? I want to write it.
The sum of clockwise moments.
The sum of clockwise moments about any point is equal to the sum of
anticlockwise moments about the same point.
So I'm simply writing. I'm going to write this. I hope that is a sufficient abbreviation. What does this mean?
Anticlockwise moment.
Anticlockwise
moment. But that is the condition that we are going to apply. So can you now look at this diagram? I hope we can see the diagram.
Yes, teacher.
So this arrow points in that direction. This arrow points in that direction. So can you give me the anticlockwise moment?
Anyone?
U1 is equal to 1.
Is the P times C?
Clockwise. It's 1 times 20.
It is 1 times C. What is the distance?
20.
And this is
equal to
P times
distance 2.
So I substitute 1 times what is this distance?
0.20.
We can write 20 because the units are the same. This is 20.
20.
These units will cancel, so I don't need to convert. Together, girls?
Yes.
Yes, teacher. So the units will convert. So what
1. That's 20 is equal to 20p.
20.
P is equal to 1. 1 Newton. 1 Newton.
For maintaining the unit. But what is the question asking me?
It's asking us to find the mass that must balance the rule and suspend
the mass. Determine the mass that must balance the weight of the ruler, okay? So we are looking for mass. So what do I do? This is the same as M?
Mass is mg.
I don't know this mass, but I know that G. Are we okay?
Yeah. Yes,
teacher. So what is the M? is 1 divided by 10, which is the same as 0.1 kilograms. 0.1 kilograms. So the required mass is 0.1 kilograms. Somebody
But Joanna,
Unmute your mic.
who is following on our behalf? Please go and mute that photo.
Okay, it's only one.
Okay.
And there's a person from
Guys, that is a simple introduction. There are so many aspects that we have introduced. One, this question was not the easiest to start with because I did not give you a diagram. You drew your own diagram. Okay, we presented our own diagram, and some of our questions are like that. So we have to interpret the question by drawing the correct diagram. It is one. We don't want to exceed so much, so we are only going to answer questions.
Unmute and submit. Increase your volume. Yes.
It's not a question.
Yes, we can hear you.
I just want to see the question again. I didn't get it well.
Okay. Those who got the question well and they have questions.
Ayoki, unmute and submit.
Teacher, I had an internet disturbance when you were converting the 1 newtons to kilograms. But my question is, why does the final answer have to be in kilograms?
Okay, you can put it in grams. Because the question is has to determine the mass. Determine the mass. And the units of mass are either kilograms or grams. So you should have this answer either in grams or in kilograms. Have I answered you?
Yes.
Okay. Other questions?
Okay, there's Donna, unmute and submit.
Yes, she was asking that. Were we supposed to write this question, or it's just an example?
Okay. I don't know what. Shona, seriously speaking, let me ask you this hypothetical question. What does your common sense tell you?
No.
So if your common sense answered you, do the needful. Do the needful, please.
Okay, thank you, teacher.
Yes, next question. Hey, if you had questions.
Yakub says, teacher, isn't the meter supposed to be slanting with a shorter side up? Because the distances are not equal for it to be balanced.
That was a diagram, and the question is telling us that the meter rule was balancing, so we follow the question. Maybe our representation on the board was not that clear. I could not align it properly, but was supposed to be balancing. Okay, so balancing, it is in equilibrium. That's what we mean.
Then Joanna search from the chart. Teacher, is there a way of knowing what distance 1 or distance 2?
Yes, we have just done them. Moreover, presentation we are done from the students themselves. The moment you capture the right information, you represent it in a diagram, you will always be able to get the correct distances. Like I told you that I started from a highly, maybe the question that we started from the higher level. Because we have to draw our own diagram, we have to make our own interpretations, and therefore we have to determine our own distances. So all those concepts I think I've captured, but they can assist you to answer the simple questions that are in your notes.
Teacher, is in the unit of moments, Newton centimeter or Newton meter. In the previous number, we worked Newtons with centimeter.
Okay. Mr. Salime, help me answer why we did not convert.
Okay, Rosemary, about the units. The reason as why we did convert at this point, when you were substituting the formula, because these units are the same. When you look at this is a centimeter and this is a centimeter. So when you come to the substitution in the formula,
You can't see.
sorry. Okay, so when you come to the substitution, if you put a centimeter there and a centimeter there, they cancel out. So because of the equal signs, we did have to convert the distance to meters because the units cancel out. If they were not canceling out, then you have to convert the given distance to meters because the standard unit for the SI unit for distance is meter. Hope we have answered you from the chat.
So I think can we leave it at that for now?
Yes. Okay, just one more is the gravity always 10. Mass layer, gravity is always 10 in all level. We maintain it and it's always given. Okay, thank you so much, Mr. Bato.
All right.
And the